And it should be time. We're good to go? Okay, so let's film this inequality. As I said, the inequality aspect is not a curriculum requirement. If that would have said equals, it would have been a curriculum requirement. Traditionally, we don't do things this tricky in grade 11, but it's a curriculum requirement. Might as well do it now because everybody has difficulty with it in grade 12, or many do, yeah.
Are we doing the one that,
Yeah, we're just going to do clean. Okay, so what's the first move, people? What's the first move? What is the first move? Close the door. Bring it forward to the other side. When you bring forward to the other side, what do you have on the other side?
0.75 minus 40.
Which is what? Minus 0.25, which is the same thing as minus a quarter. Do you flip the direction of the inequality when you make that move? Why?
Because
you only flip the direction of an inequality when you do what to both sides?
divide
or both sides by negative. Are you doing that in this case? No. So you slide that over, make it minus 4. 3.75 minus 4 is minus a quarter. And then we want to get rid of this on both sides. So we divide both sides by this, which is the same thing as multiplying by the reciprocal of it, correct? So this will be there, this will vanish on this side. We'll have sine of, I'll turn this into minus 360 over 60 times 6 is 360. That becomes 30 PA. Why did I do that? Why did I change that into minus 360 over 30?
360 is a period
of what?
A sine function.
Of a sine function. If this was cos, would I also make this 360?
Yeah.
Yes. If this was tan, would I make this 360? 180. So the period underneath, sorry, the value underneath is the period of the transformation. And it has to go along with the period of the parent. So if that is I parent, that's 360, that means you know the period of your transformation is 30 PA, 30 pascals. Okay, so we said like this, and we said take away over here minus a quarter, which is minus 1 over 4 degrees C. I'll leave the units out. We're going to divide both sides by that or multiply by the reciprocal. I believe you're going to correct any mistakes that I make. And this whole thing goes to minus 3 over 8. Is that correct? Okay, now we're going to call this thing, we can call it anything we want. I think we've been calling it K. Agreed? And we're going to say that K related acute is going to be equal to the inverse sine of the abs val of whatever I have over there. What does absolute value do?
Make it positive.
Makes it positive. Okay. Why do I want to make it positive? And does that abs valness have anything to do with the letter R?
So can you...
Is this R and these lines, are those things related?
Yeah.
Yes. You always want to take the positive value because that will give you the related acute angle. R stands for related acute angle. If your ratio is positive, you're going to get a solution in quadrant 1, okay? Which is less than 90 degrees because that's between 0 and 90. Then, once we get that answer, we're going to backtrack and look at the sign of the last inequality, not the first, the last, in conjunction with the cast rule, to figure out where our answers actually lie. Who sort of follows that? That's the most difficult part of all this. At the very least, if you can get it recipe-wise, that's good. But ideally, eventually, I want you to understand the thing completely. So, what is the inverse sine of 3 over 8 in degrees? I think it's, what was it? 22-ish? 22.02, we'll say roughly 22. And that is going to be degrees. Agreed? Okay, so now I'm going to use the cast rule. I think it goes like this.
Yeah.
And what do I need? I need to go back to my last. Do I go to the top inequality? I go to the last thing I created before I did this K business. And the last thing I created was this one. And I look at the sign over there, and it's negative. And I look at that information in conjunction with the parent function that I'm using. And I look at those two pieces of information. And based on this piece of information and that piece of information, which two do I circle?
T and C.
Nice. T and C. Because sine, correctly pointed out here, is negative in quadrant 3 and 4. Agreed? So, what does that mean? We have a related acute angle of 22 degrees. By taking the abs val, we are in control of what the solutions are. We use our brains along with the cast rule to decide what the appropriate solutions are. That's why we take the positive value. So doing that, what this means to me is we have one answer in quadrant 3, which means going 180 degrees plus a wedge of 22, right? And 180 plus 22 is going to give us 202 degrees, and we call that our first solution of K. Agreed? And then our second one, we said, is in quadrant 4, which is the same thing as going a full 360 and backing off 22 degrees, a wedge of 22, right? And that gives us 360, take away 22, what is that, 348? Is that 348? Because you know my arithmetic is not good.
338.
338, thank you. 338. Okay, now, any questions on that so far? The thing is, we have to give solutions in terms of the independent variable p. And right now we're dealing with degrees. But we know that K was written as this. K was written as minus 360 degrees over 30 pascals, P minus 500 degrees. And if I isolate for P, I can bring the minus 500 over, divide both sides by this, which is like multiplying by the reciprocal of this, I believe, which is going to be minus 30 PA over 360. No, you don't have to make it 360 over 30, you can make it 12, and you technically don't have to write units, but I like to when I'm teaching it. Assuming that I'm doing this right. Looks pretty good to me. Pressure 1 comes out to being what? It's going to be, what's the first one? 202? 202 plus 500 times negative 30 pascals over 360 degrees. Look at the beauty of this. You have degrees and degrees. They offset with degrees, and you get a solution of units of Pascal, which makes sense. What is the number? You guys will give me that. It's going to be 202. This one's going to be 338 plus 500, assuming I've done all this right. I need two numbers here. Anybody? Calculators, come on, get your calculators out.
58.5.
What's the first one?
58.5 negative.
Yeah. Yeah. And the other?
Negative 69.8.
Okay. Now we get to the difficult part, the second difficult. So to me, the first difficult part is making this decision here. And to me, now this becomes the second difficult part. If you actually look at this formula that we built over here, what it really is, you know the mapping formula? Remember that thing? Remember that thing? X comma y becomes 1 over bx plus c, ay plus d, for y is equal to af bx minus c plus d, right? This thing here, I don't know if you remember, but the way that thing is generated, okay, is by taking the final value and isolate. Where is it? This equation right here. K is equal to this. When you isolate for P in terms of K, what you're actually getting is this. That's what you're getting. 1 over bx plus c, which is good. It's what you want. It's telling you where the x values on the parent function, or the independent variables, values on the parent function, get moved to on the transformation. And the reason why that's good is as follows. Let's look at what our parent function is. We go to the final inequality. I'm going to go to this thing, the left side. The left side of this thing. I want to create a little sketch. Okay? For inequality reasons, we need a sketch, I think. For quality reasons, I don't think we do. This is a sine function. Agreed? So if my parent function there is a sine function, let's imagine sine going up. Traditionally, the parent function goes like this, right? Goes like that, goes up and down. And this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. Agreed? Our two answers corresponded to quadrants 3 and 4. Now we are not going to be operating in terms of degrees anymore. Now we are dealing with this whole thing as a function of pressure, but that's okay because it's 1 over bx plus c. It's going to take our answers that were in quadrants 3 and 4 and move them to the corresponding quadrant 3 and 4 answers for the transformation. And so those would be here, right? Okay, so what's 1? One of the answers is, where is it? Minus 69.8. It's minus 69.8 degree, no, pascals. And this is what? This is minus 58.5 pascals. Now here's the thing. That corresponds to equaling 3 over 8. So 3 over 8, sorry, minus 3 over 8. So minus 3 over 8, let's say it goes like this. Let's say this is minus 3 over 8. We'll say left side of last inequality equals minus 3 over 8. Okay? This thing, we want to know when this thing is bigger than minus 3 over 8, when it's above, okay? These 2 points correspond to when it's bang on minus 3 over 8, right? Do we agree that our solution lies over here and over here? Do you guys agree with that?
Yeah.
If this is one cycle, this part of the cycle is above that line, and this part of the cycle is above that line. It's kind of ugly, right? And this is where I think I got tripped up. So if we continue this, right, and go like that, if we take this point, right, and we add 1 period to it in terms of the independent variable, which is Pascal or pressure, which is 30, minus, there's 1 cycle, boom, the next one is going to be right there. I didn't draw it too well. This shouldn't be as low. It should be more like this. This point here, do you agree that this point here will be equal to this point plus a full period along? So that's going to be minus 69.8 Pascal plus, what's our period? 30 Pascal. What does that give us? Help me out here, my head already hurts. Minus 39.8 Pascal. What I think we should do is quote from here to here in a cycle. See this next cycle going? We want to take this. This is our answer. This point over here is going to correspond to this, right? Plus 30. Minus 58.5 PA plus 30. What does that give us? Minus, what is that? 28.5 PA. But this is the below part. This is the above part. What do you think? Huh? Do you guys see that? It's hard, right? It's tricky to see. Because look, here are the answers we got for our first cycle, right? Well, these are the answers we got for our first cycle in degrees. That and that. Then we backtrack. We use the formula for this to isolate for P. We put each of these 2 angles into the same formula, and we get that this corresponding angle corresponds to this. This angle corresponds to this pressure. These 2 angles were in quadrants 3 and 4. On a sine function, that means go up and then you dip down, right? It's the last 2 bits of the dip of the smile, right? going down and back up to complete the smile. So I draw that, and then I think, okay, there's one answer. Like, there's let's say that the dip starts there, right? So one answer somewhere in the middle of the third quadrant, and then another answer somewhere in the third quadrant. And then we say, okay, well, our inequality is what I've circled in red, and it's got to be bigger than minus 3 over 8. This was an equality. I wrote equals 3 over 8. So these are the points that lie right on 3 over 8, but we want it to be bigger than minus 3 over 8. And this is hard to, it's like you want to take this bit and this bit for that cycle, but it's disjointed. Wouldn't it be nice? We'd have to go, we could do it that way. We could say, you know, from here to here, union from here to here. But if you just continue the next cycle, right? If you just continue the next cycle, and you add a cycle to this point, and add a cycle to this point, you get these 2 points. And what you see is that in the next cycle, you can quite clearly see that these should be the endpoints that you should use for the part of the thing that is above minus 3 over 8. Does anybody see it? Nobody? Oh, great. Then I'm probably wrong. We'll see if I'm wrong. Now, I'll finish it. We'll see. Maybe I'm wrong. So what is this one? This one's minus 58.5. And what is this one? This is minus 39.8. Now, I believe you put a domain restriction on this. I think we said that P had to be bigger or equal to 0. Can we say bigger or equal to, or whatever? Like that? Okay. So, if these two are the ones I want to use, from here to here, and this one, we'll go back over as many times as we need to. If we add 30 to that, we're still below 0. If we add 30 to that, we're definitely still below 0, right? But if we add another 30 to both, which is the same as adding 60, are we above 0?
Yeah.
So if we add 60 PA, what do we get? 20.2.
Yep.
And if we, where's the other one I was talking about? This one over here. And if we add 60 to that, what do we get? 1.5? Now, I think that my answer is going to go like this.
Wait, sir.
Yeah.
You added 90 to 69.8, but you added...
No, I added 60 to each.
No, the 69.8 plus 60 is 9.8.
No, oh, wait. No, I added...
Okay, but that's not the number, though.
Wait, maybe she's right.
I see what you mean.
No, I see what you mean. I added 60 to this one,
Yeah.
and you're saying I should add 60 to... Oh, right. 60 isn't enough. You're saying I have to add 90 to this one,
Yeah.
and then you're saying I have to add 90 to this one, too. Thank you. Thank you. So that becomes, what, 31.5?
Yeah.
Yeah, you have to add the same amount. So 3 periods, not 2, to make sure both are above negative. So, yeah, because if you go back a period on this one, there's still a little bit, isn't there? We have to think about that. Is that, well, we'll think about that little bit. Is that little bit that's missing above minus 3 over 8 or not? We'll think about it. But at the very least, I can say this. 20.2 Pascals plus 360 N, comma, where's the other one? 31.5 plus 360 N, where N is a whole number. Why didn't I pick integer? Yeah.
You made the same mistake as you did yesterday.
No, I did not.
That is, it's supposed to be 1.5 to 20.2.
Well, let me see. So, where did we start? I was here, right? Oh, yeah. No, I was right. I was right the way I did it.
Yeah.
I'm supposed to add. I was right. I was supposed to add
60.
I was supposed to add 90 to one and 60 to the other because
Oh my god.
where did it start? Where did it all start? Minus 69.8 I took that and I added a cycle to it. So I added 30 to it to get to here, which gave me minus 39.8, right? Which is this point, which was good. And then I took, okay, yeah, and then I looked at this point, which was the second of the original two, and I recognized that from here to here is what I want. Now I want to take these 2 points and start bumping them up. If we do it the way you suggested, we're just bumping up from the original 2. I wanted to take the first point here, move it to here, to the second cycle, and take the front end of the second cycle. So I was right. I was right. So, what does that mean? Where do I fix it? So plus 30, and then plus 30.
No, that's still plus 60.
This is still plus 60? I'm confused now. So which is the one that I added 92 that I shouldn't have?
The bottom one.
The bottom one?
Minus 58.5.
The minus 58.5?
At the very bottom.
Here?
Yeah, that should be 60.
Yes. 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 Do you guys understand why? No. You do. Yeah, we'll go over it again. We'll go over it again, okay? Imagine that we come back to this point. Minus 58.5 and minus 69.8. There they are. 1 and 2. Agreed? And look at the cycle here. I drew the cycle in white. Solid white. So that we can recognize it. This is that first cycle. We're going to stop it right there. And there's one answer. And there's the other answer. Within that first cycle, do you agree that you are above, this line is minus 3 over 8, you are above that line here and here?
Yeah.
Okay? If you want us to keep things like that and just do what she suggested and just bump up both of these points, we could do that. Watch. If we could just add, what do we need to add? 90. We could add 90 to both of these, and then you would end up with the same picture, okay? And you would say you are above this line from here to here, union from here to here, plus 360n. Okay, you could do that. But it's uglier, it's messier, because you got 2 bits. And then I think also we're missing the 1.5 bit. So what I did was, I wanted to make this just one block. So I took minus 69.8 and I added it. I added 1 period to it to put it here. Right here. Put it right here. So minus 69.8, right? Plus 30, put me right here. And now I'm looking at this second cycle. And looking at this second cycle, it becomes clear to me that in this second cycle, I can just quote this part of the second cycle, that mountain, as being the part that is above minus 3 over 8. You see that? So now I'm dealing with these 2 points. But what are these 2 points? This point is the second point that we had. This point is that point plus 30. Now I'm going to move these up in pairs. These 2 up in pairs. Doom, doom. I'm going to move them up in increments of 30 until I get over 0. Yeah.
You said plus 360 and shouldn't it be 30 because the period is 30?
Thank you very much. This is not right. Right? This is 30. This is technically 30 PA, 30 pascals times N. And this is 30 pascals times N. Yeah. Wait a minute. And did we fix the numbers up there?
20.2 should be 1.5.
I don't know. You guys don't seem convinced. Yeah?
How do we know that we have to like bump up like 30 and then like use it as a pair?
Okay, you don't. You don't have to. Let's do it this way. Let's do it this way. Let's take a look at this first cycle here, okay? This particular portion, we would have to figure out, this would have to be extended. We would have to extend, well, we would have to do something, because look, we'd have to extend this down, right? Actually, no, we don't. No, we do. No, we would have to figure out what this is. If we want to do it this way, don't we need to know what pressure that is at? Because this is a cycle, one cycle from here to here, right? So we would need to know what this value is and quote it all the way to here. And then we would have to go from minus 58.5 all the way to that point, right? I mean, look, that's where the white thing is above the dashed line. It's annoying. Yeah.
Why is 20.2 changed to 1.5 and not 31.5 changed?
I don't know. I have to look carefully. I have to look at everything here. This moved to here, which became minus 39.8, to which we added 60, which became 20.2. Isn't that here? Yeah, I'm a little confused by the numbers now too. Isn't that the 20.2?
Yep.
And then the 1.5 was this point, yeah, which just got bumped up twice. Yeah. So minus 69.5 got moved to here, which is a bump up of 1 period. And then we added 2 periods to it, which we did here to get to 20.2. And this one didn't get bumped up first. It just got added, 2 periods got added to it. So it's going to be quoted first, 1.5, 20.2. Whatever, we've got it on video. You can look at it, think about it. Can I get a show of hands of those? It's those of you who get it. 1, 2, and that's not enough. So who gets it 100%? 1, 2. Rosemary, no?
I have a question.
2 people. Hard. Yeah.
From the solution for P2 solutions, how do we know that those are the 2 points on the graph? Because of quadrant 1, 2, 3, 4.
Well, how do you know that you're always going to have 2 solutions? If you go back here, right?
We know I have 2 solutions,
Yeah.
yes.
Yeah.
How do you put those 2 solutions on the graph? Say why they are there, not there.
So what I do is, because when you isolate for K using this formula, right? Because what you are doing is getting this formula, okay? What it's doing is it's telling you where these 2 points on the on the parent function get moved to on the transformation. Now, where do these 2 points lie on the parent function? They lie in quadrants 3 and 4.
Okay.
So I just draw, excuse me, if you wanted, you could sketch this more accurately, but I don't need to. I just start a sine function. I start a squiggle right here. And I go, and I finish it. Okay? And then I just draw a line in space that represents minus 3 over 8. Okay? Then I say to myself, okay, well, I know when you draw a sine function, the first half of the upsweep is quadrant 1, the second half is quadrant 2,
Okay.
then quad 3 and quad 4.
Yeah.
So I know that these 2 are in quad 3 and 4, somewhere in the middle of there. So if this is the halfway point here, this starts quadrant 3, right? And I put an answer here, and then this is quadrant 4 up to here, so I put an answer there. These 2 corresponding pressures, okay, which came from 202 and 338 degrees, correspond to the locations on one period of the transformed function where you would equal to minus 3 over 8.
But if that's the case, shouldn't solution 1 be correspond to solution 1, which is negative 58.5, be on the quadrant 3 point, and negative 69.8 on the other point?
Nope, because you have because B is negative, so it's reflected.
You didn't draw a reflected way.
I don't have to.
You don't have to.
No. So, like, if you had a sine function like this, right, and you just, if you had a sine function like that, right, and you did a reflection of it. This one going like that. and you did a reflection of it like that.
Yeah.
And then you look at, we can pause it because this is